Okay, so lesson 5, we're looking at, it's called finding exact solutions for coupled differential equations. So in our course, we learn how to find solutions to differential equations that are in this very particular form. We need to talk about a couple of things notation wise to start with, and that is that the x with the dot above it, we can see here the dot notation indicates that a variable has been differentiated with respect to time. So when you see x dot, that's actually shorthand for dx dt. Y dot is shorthand for dy dt. So we have the derivative of x with respect to time is ax plus by. Derivative of y with respect to time is cx plus dy. Next thing is that we can write this system of equations. This is simply a system of equations in a matrix form. So we're going back to matrices. Yay. And to write this as matrix form, we'd write dx dy or dx dt dy dt equals AC matrix ABCD times matrix XY. If you remember why that's true, it's because we can multiply rows by column to get the first row, which would be AX plus BY. You add, so you multiply the corresponding elements, row or A times X plus B times Y, which is what is up here. And then for the second row, you would multiply C times X plus D times Y, rows times columns, which is what is there. So this is how to turn a system of equations into matrix form. And then this next notation is a little bit weird. We're using it because it's kind of how IB writes it. But what we have here is that x dot is a vector. We're going to say that x dot is bold. And if you remember, when something is bold, it is a vector. So we have x dot is the vector x, is actually going to be, for us, it will be the vector x dot y dot, or dx dt dy dt. So it's actually representing dx dt dy dt. Next we have, so, and that's like vector x. Oh, sorry. And then vector x here is xy. And so what we're doing is we're rewriting this statement in shorthand form like this, where M is the matrix A, B, C, D, like so. And so we have M is A, B, C, D. Okay, we're getting somewhere. Let's getting the nitpicky stuff out of the way. So to find the solution to the system, remember, a solution is we want to find in the end what x, y is equal to, because what we're given is dx dt dy dt, and we want to find x and y alone. The original functions is kind of the way I think of it. And to do that, we're going to use eigenvalues and eigenvectors. Lambda 1, lambda 2 are our distinct eigenvalues of the matrix ABCD. P1, P2 are their corresponding eigenvectors. Remember, these are vectors, they are bolded. And down here in the solution, so the solution to the system is this. Remember, this is actually x, y. Is equal to this. And then vector P, vector P1, so let's see, P1 is actually an x and a y also. So it's like P1, the x value for P1, and P1, the y value for P1. And then for vector P2, same idea here. So P1 and P2 are vectors, keep that in mind. In front, these are not vectors, that is some exponential in terms of t here. It's all really abstract right now, I know that, but I want to get into the notation. You can see down here, this is how it's written in the formula book right here. And in the formula book, they also write x equals, but that again is a vector, that is xy. And so that's why I wanted to go through this really clearly, because you get the formula book, but it's a bit confusing if you don't understand that that is a vector. Last thing is, let's remember what eigenvalues and eigenvectors are. So if you take a matrix and multiply it by the eigenvector, it should be equal to lambda times that same eigenvector. So for instance, I have a little example. So this is our last little part for this video. A little bit of review. I'm not going to show you again how to find eigenvalues and eigenvectors yet. We'll do that in a second. But trust me right now that this matrix has an eigenvalue of 3, and the corresponding eigenvector is 2, 2. And so what that means is we should be able to multiply that matrix 1, 2, 2, 1 by 2, 2, and it should be equal to 3 times 2, 2, because that is our eigenvalue and eigenvector. And we could double check and make sure. Rows times columns, 1 times 2 plus 2 times 2 is 2 plus 4. And then the next row would be 2 times 2 plus 1 times 2, 4 plus 2, which is clearly equal to 3 times 2, 2, which is 6, 6. So that is a eigenvector with, or eigenvalue with a corresponding eigenvector. We'll go through the process of how to actually find these again in example 2. But for right now, that's just the basics of notation.